Hello and welcome to another installment of Coleman University's Professional Development Training Amplification series. Today we'll take a few minutes to look at some of the tools available in Moodle to assess the quiz results and how to modify your quizzes based on those results. We will cover a few basic statistical concepts, as we know it may have been a while since many of you have sat in a classroom on statistics. If you're rusty on your basic statistics, don't worry about it. These Moodle tools will do all the hard work for you. We are going to define the metrics for what makes up a good quiz and examine the statistics that are generated by Moodle that can help us assess our own quizzes and the inherent questions within them. Finally, while on the subject of quizzes, we will look at some of the best practices to avoid cheating and some of the indicators that cheating may have occurred, which you can use after the test is over. In statistics, the assumption is that any large number of items will form a bell curve when assessed on any continuous characteristic of those items. This is also referred to as a normal distribution. Some of the ways that we can measure the characteristics of this distribution are through the measures of central tendency, such as the mean, which is the mathematical average of all the values, and since we're talking about quizzes, I'm going to call those values scores from now on. The mean is not necessarily the highest point on the curve. Its position relative to the other measures gives you an idea of how the curve actually looks. Experts in testing set the golden area for the mean to be between 50 and 75% of the maximum score. You may find that this area moves somewhat to the right in your smaller classrooms. The other measure of central tendency that is provided by the system is the median. This is simply the midpoint of all the scores laid out from lowest to highest. In a perfect bell curve, the median, mean, and mode, the most common score and the highest point on the curve, would all lie at the same point on the curve. The further apart these measures are, the less your results resemble a bell curve. In addition to the measures of central tendency, we have a measure of dispersion that is offered by the system, standard deviation. Standard deviation is a calculation of the area under the curve and centered on the mean required to capture approximately 68% of the scores in the population. The larger the standard deviation, the more diverse the underlying population, while the smaller the standard deviation, the more similar the scores are from the exam. Another concern with the shape of the curve is how far it bends away from the traditional bell curve shape. The measure for this is the skew. Positive skews means the curve is bending backwards toward the left or lower end of the scale, where negative skews indicate the curve is leaning forwards toward the higher end or right side of the scale. The number value indicates how strongly the curve leans in the given direction. Generally, we find tests have a negative skew. That is, more students do well than do poorly on exams. A final measure, again dealing with distribution or the variance in the scores, is kurtosis. Here we measure how similar the scores are. High kurtosis values indicate little variance in the scores, while low or negative kurtosis values indicate widely ranging scores on the exam. That's all we need to know in terms of basic statistics to be able to examine the metrics provided by Moodle to determine the quality of our quizzes. But that does seem to beg the question, what actually does a good quiz look like? Sure, you can find hundreds of answers for this, but they really boil down to just three basic descriptors. 1. The quiz should be fair and not culturally biased. That is, it measures 2. What was actually taught regarding the course outcomes and not instead testing some other attribute such as knowledge of the language or covert cultural values. Unless, of course, this happens to be a course on language or cultural values. Most people will agree with the first two descriptors. Quite often we get pushback with a third descriptor. 3. Good quizzes discriminate among students. We don't mean discriminate in the common negative sense of the word, giving favor to one group while disparaging a second group, but rather the statistical and scientific meaning of discriminate, which is to tell one from another based on characteristics. Being able to tell the difference between an apple and an orange, that is to discriminate between the two. It does not imply that you love one and hate the other, only that whatever technique you use to separate them is successful and consistent. Good tests must be able to segregate, another word with significant negative connotations in the real world, but meaningful in statistics and science, high-performing students from low-performing students. Apples and oranges. Otherwise, tests have no real value in determining learning. They merely are ways to gather or lose points on the way to a final grade in the class. From an operational perspective, a good quiz is one that meets these criteria. And no, before you ask, I have no expectations whatsoever that any of you in this course would actually do the math to find these numbers out. That's why we have computers. I do not want you to run any statistics. What I want for you to be able to do is to understand the results of the statistical analysis on the exam when presented to you by the software. So our focus is going to be on the meaning of the results, not on the formulae and methodology required to gain them. That's outside the scope of this course. Once your students have taken a quiz, simply open the quiz and move to the navigation menu under Administration, select Quiz Administration, Results, and click on Statistics. This will open up a very long page of results for you to review. To make this simpler, we'll break the page into 3 parts. The first section provides general quiz information. It allows us to get an idea of what the results look like, an overall feeling for the quality of the exam. Quality being defined as the exam's ability to discriminate strong from weak students. In the beginning of the table, the total number of quizzes taken is shown, along with the average. As mentioned earlier, the golden or butter zone is 50 to 75%. As we can see here, this exam's mean is much higher than the recommended zone, meaning students scored far higher on the exam than they should have if this were a good exam. The median is quite high and to the right of the average. This means that half of the class scored at or above 93%. Because the median is to the right of the average, we can make the assumption that this is a skewed distribution with a negative value, meaning it is skewed to the right or the higher end of the scale. The standard deviation is slightly lower than the acceptable range. What this means is that in the range from 87.5 plus 10.5 or 98% score down to 87.5 less 10.5 or 77% score contains 68% of the students in the course. The acceptable range is from 12 to 18%, and smaller values, such as the one we see here of 10.5, mean that we don't have appropriate distribution of student scores in our exam. Our earlier assumption of skewness is proven with a calculated metric showing a heavily skewed curve to the right. Negative 1.0 is the appropriate limit to the skew, and this test has almost 2.5 times that, meaning it's going to be very difficult to discriminate between good performing students and those that did not perform as well because their scores on the exam are not that different. This agrees with the basic measurements discussed earlier and shows that this appears to be a fairly easy test. Kurtosis, again a measure of distribution, should lie between 0 and 1. This exam has a value of 5.75, a strong indicator that this exam would not be able to discriminate between good performing students and average performers based on their scores on the test. The coefficient of internal consistency, or CIC, should be in a range between 90 and 75%. Any CIC values below 64% indicate an unsatisfactory test. The lower the CIC value, the greater the odds the differences in scores are based on random chance or guessing than on the performance and preparation of the students. For this exam, we have an acceptable CIC value. This would indicate that there is a low likelihood that the differences in scores are due to random chance. The error ratio must be below 50% in order for us to claim this is a valid test. The higher the score, the more that the width of the standard deviation can be assigned to chance or random variation. While the score is within acceptable limits for this exam, it is rather high. Finally, the last of our quiz information metrics is the standard error. The acceptable zones are from 5 to 8%, with anything above 8% indicating a strong influence of chance or guessing in the results. Here we have a low score for standard error. Scrolling down the page, we enter our second segment, the quiz structure analysis, which provides us a question-level view of the statistics for the exam. The questions that do not meet the most basic criteria are highlighted in pink, including one question, number 10, which exhibits negative covariance. What this means is that the question appears to be measuring something other than what the exam is supposed to be covering. It could simply be a bad question, as in the case here where there is not a clear answer. Negative covariance indicates that the better students were more likely to miss this question than were the weak students. These sorts of questions should be examined and perhaps dropped from the test and the student scores, or edited for future versions of the test. By clicking on the question name link, we can see the same statistics that are shown in each row of this table, but we also see the question itself and the distribution of the various answers. We will use one of these pop-ups as a way to examine the question-level statistics. As you can see, at the top of the pop-up is the narrative of the question stem, while at the bottom are all of the potential answers along with the percentage and numeric count of student responses. This is a quick and easy way to determine if there may be an error in the question itself. For instance, 2 answers that are in fact correct rather than simply 1. It is also helpful in determining student confusion. If the majority of students choose a wrong answer, it would behoove the instructor to try to determine why. Was the stem confusing? Were the topics not covered clearly in class? Or did the students simply misread the answer choice? Moving beyond this simple check, Moodle provides a number of very telling statistics about each question. First, the facility index provides the mean score for the question, and the goal is to get between 35 to 64% for this metric. The closer that FI is to 100%, the easier the question, with 100% itself meaning everyone got it right. And an FI of 0 means the question was very difficult and no one got it right. Quick sidebar, results like this don't necessarily mean it's a bad question. Instructors need to go back over their notes and ensure that the material was actually covered. If it was, then it's likely that the question is worded poorly or there is some other internal problem that confused students. The standard deviation is the spread of scores around the mean, and the goal is somewhat below 1/3 of the question value. Since the default value of a question in Moodle is 1 point, that means 33% is the maximum value that should be shown in this area. The random guess score is not very useful to the instructor, but it is used in the remaining calculations. It's fairly straightforward. If the multiple choice question has 4 options, then the student has 1 out of 4 chances to get it right by randomly guessing, or 25%. Using true-false questions on an exam is not encouraged as it inflates the RGS. Like the random guess score, intended weight is a simple calculation based on the nature of the test. Assuming that the instructor has not weighted any question more heavily than another when creating the exam, the system default is to give each question an equal value of 1 point. The system will then calculate the intended weight, taking the test's 100% and dividing it by the number of questions, weighting them if the instructor did so, to determine how much of the total quiz's score should be made up of this question. For this exam, with 30 questions, the intended weight is 3.33. 3.33 times 30 equaling 100%. Unlike the simple calculation of the intended weight, the effective weight is the actual measure of how critical this one question was in determining the final score on the exam. If the estimated weight is greater than the intended weight, then this is considered to be a hard question. If, on the other hand, the estimated weight is less than the intended weight, it's considered easy. As you can see in this instance, it is yet another indicator that this was a very easy question. One key measure is the discrimination index. This determines how effective the question was at segregating strong from weak students. DIs of 30 or more are considered adequate, while DIs greater than 50 are very good. As you can see, this question had little effect on the overall differences in score between strong and weak students. The final question level metric is the discriminative efficiency, or DE. This balances the strengths of the discrimination index against the difficulty of the question. However, this metric can be affected by the facility index. If the FI score is outside the range of 30 to 70%, this metric may not be as valuable. The hope is to gain DE scores of over 50%. As you can see in this case, the facility index is quite high and the DE is quite low. Assessing all of these metrics together indicates that this is a very easy question that does not provide any worthwhile discrimination in the exam and only acts to pad the total score. As a result, it should likely be dropped from the test bank. Moving back to the quiz structure analysis table, use the back page of the handout to see if any of these questions look reasonable and should be kept. The only one that meets the majority of the criteria is number 9. Fully understanding that most people are not good at assessing a table of data, or just have no desire to do so, Moodle provides a third segment of this page, a graphic representation of the table. Here we see the problem with number 10, the question with negative covariance, and it should be dropped from the quiz after determining what the problem may have been. In this case, it was a poorly worded question stem that did not have a clear answer available. While this graphic looks very busy, we can use some of our rules on the use of metrics to simplify it. We know, for example, that the facility index should be below 80%. We also know that the discriminative efficiency should be above 50%. This leaves us the range for appropriate questions. In this entire midterm exam, only 2 questions are in this appropriate zone. Unsurprisingly, question number 9 was one of the 2. By winnowing away the very easy questions or rewording them to make them more difficult, over time, an instructor could bring the majority of his or her exam questions into the appropriate zone. Doing this would affect the overall exam metrics and bring them into compliance as well. The simplest way to do this, over time, is to share question results among faculty teaching the same course. Start with sharing the publisher's test bank. Remove the easy questions that do not discriminate, and earmark those that do. Over time, the faculty will change the shape of the test bank and bring it to the appropriate level of discrimination for their target students. This plan will allow quizzes to act in the way they should, as indicators of superior student performance. Because many of our courses have fewer than 30 students seated, take these ranges of appropriate results as general guidelines. Classes with fewer than 30 students are more likely to have results skewed due to individual student performance and are not likely to reflect a bell curve. Shifting gears then. If we have an exam that we know is a good one, meaning it discriminates between strong and weak students, students may be tempted to cheat to defeat the discrimination. It is not feasible to remove all possible sources of cheating. Instructors can, however, minimize the chance of cheating occurring in their classes by both using the tools embedded in Moodle and good instructor practice. First, ensure no digital devices, other than the computers the students are taking the quiz on, are available. This means placed in backpacks, on the floor, or even on a separate table. Students have been found to cheat by having their phones in their pockets on vibrate and essentially using code to send answers to each other. Use the security settings and shuffle features within Moodle to minimize the value of the wandering eye. Shuffle the question order and the order of answer options. Do not provide immediate feedback during an exam. If the students are taking quizzes on lab computers, you can use the browser security option to have the exam pop up and cover the screen, and not allow students to open another window to do things like Google searches. While this also works with remote computers, you need to ensure students are warned to either turn off their pop-up blockers or to allow pop-ups from the school site prior to the exam. Otherwise, students may end up starting an exam that they cannot actually see because the pop-up has been blocked. You may wish to create a short one-question quiz prior to the actual exam to allow students to test their system. To the greatest extent possible, space students out so that it becomes more obvious when they try to read another student's screen or use illicit materials. Immediately stop any sort of noise, such as tapping or clicking in the classroom, as these are often used to trade information. Have all materials, backpacks, coffee, watches put away and out of sight. Students have been known to use the position of items on their tables to send information to other students. Finally, keep a close eye on the students. Wander amongst them so they're never sure when you're going to be around. While you may consider this distracting, typically it is only distracting to those students who are waiting for you to turn your back so they can cheat. But what about after the test? Can we catch cheaters after the fact? Well, if we have an excessively easy exam, such as the one we've been looking at, catching cheaters is incredibly difficult. In order to catch cheaters, we really need to have some wrong answers. One of the ways to catch cheaters is to keep a floor plan of where students were seated. Once the exam is over, pull the results of the exam and order the students by the seating chart. All of the students in a given table in one set of data, for instance. Look for patterns in the data. If you see two students who sat next to each other that are missing the same question, you should focus on them as potential cheaters. As in this case, students spent a very short amount of time on a 30-question midterm, and barely a minute separated them. The average time it takes students to complete a test is another indication of whether the test is too simple or whether they're cheating. The first student took a mere 9.5 seconds to answer each question. The second student only took 11.7 seconds per question. In this case, speed appears to be due to the simplicity of the test and not cheating, as those times were similar to the times of other students in the class. Realize, however, that just missing the same question is not sufficient proof of cheating. If, for instance, the students had different answers for each wrong question, that would indicate that the particular question may not have been understood by some of the students, rather than the students were cheating. But on the other hand, if the students missed the exact same questions and missed them using the exact same wrong answers, the odds of them cheating increase dramatically with the number of matched wrong answers. One or two wrong answers that match is insufficient. It could instead represent shared misunderstandings of the content. But once you get beyond 5 matches, it is difficult statistically to claim this was due to just random chance. The amount of proof required to charge a student with cheating varies from school to school and resides with the dean. It is strongly suggested that you talk to your dean before accusing a student of cheating. Our takeaways for this session are to remember that the sole purpose of a test is to discriminate between strong and weak performers, not merely to add points toward a course total. The embedded statistics within Moodle allow instructors to improve their test banks and therefore their exam discrimination by evolving the test bank over time. While cheating itself is a fact of life, instructors can take actions that make it more difficult on the student to do so and therefore reduce the number of instances in their classrooms. Cheating can be identified after the fact, but it requires that instructors develop discriminatory tests and that they keep track of where students were seated during the exam. Next month's professional development training will be looking at the use of some of Moodle's tools to enhance your on-ground class. While a lot of ink has been spilled recently on the power of flipping the classroom, it involves more than simply dumping everything into the online platform. Until then, enjoy your teaching, and we look forward to seeing you in a month. Good luck.